Hello everyone. So myself Vishal. So I am research scholar. So from today we will start fluid mechanics. So this will be the lecture one. This in this lecture we will discuss some basic definition. That is definition of basic fluid stress, shear stress, what is dynamics, what is mechanics, and what is compressible flow, incompressible flow. Okay. And Mach number, then the relation between Mach number and supersonic, hypersonic, supersonic, sonic, subsonic, and viscosity and surface tension. This type of definition we will discuss today. Okay, so let's start the lecture. This is the introductory lecture one. Okay, from the next and after that class we will start our main thing. Okay, so definition of fluid. What is fluid? Fluid, what is fluid? Fluid is a substance that deforms continuously under the application of shear stress. Okay, here we getting a unknown term that is shear stress. Okay, what is shear stress? So before knowing about shear stress, we have to know what is stress. So here I wrote the definition of stress. So stress is a force per unit area acting on a surface. Example, as an example, pressure is a normal stress. Okay. If we consider a surface, this is a surface. Okay. And if per unit, suppose this is a unit area and we acting some force. So this will be the stress. Okay. And what is the shear stress? Shear stress is the tangential stress on a surface. That means this surface, the stress is tangential. So this is tangent. Then this stress called is shear stress. Okay. So a fluid at rest cannot resist the shear stress. Okay. It's obvious for shear stress the fluid must move, right, in a some direction, horizontal, vertically. So this was the definition of fluid and stress and shear stress. And next slide, we will see something. So let's see next slide. What mechanics? So if you want know the difference between mechanics and dynamics and statics, but we have to know it clearly. Okay. So mechanics is not a dynamics. No, okay. So we have to know it clearly. So mechanics. So what is mechanics? Mechanics is the application of the laws of force and motion. Okay? Mechanics is a branch, suppose. So for what? Laws of force and motion. Okay? There are two branches. One is statistics and the other one is dynamics. Okay? So statics what? If the fluid at rest, that means the fluid has no velocity. If the position of fluid is at rest. Okay. And what is dynamics? So dynamics is fluid at motion. If the fluid in a pipe, suppose the fluid is moving, then we can say that is dynamics. So we study fluid dynamics. Okay. That means we will study all thing about fluid which is moving in some direction. So this is the dynamics. So basically mechanics is two type. One is statics and another one is dynamics. Okay, I hope the definition of statics and I hope the definition is clear. So now we will see what is next slide. Okay. So for next slide, compressible and incompressible flow. So if you want to know about what is compressible and incompressible flow, so I want to just share this thing. What is so compressible, incompressible flow means if density is constant. Okay, if a fluid flow and the density of fluid density means mass by volume of this fluid. That means density is constant. Then the fluid flow is incompressible flow. Incompressible flow. Okay. And when it will be compressible, if the density, if the changes in density is significant. Okay, that means we can see the density is changed. That means we can get the value of density is variable. Variable means vary. So that is compressible flow. So the example of compressible flow is suppose air, gas. Gas is the example of compressible flow, and for incompressible flow, the example is water, water, oil. Sorry, this is oil. So, so this is oil. The example of incompressible flow. Okay. So now we have to know what is Mach number. Mach number is a very important thing. Without Mach number, we can understand what is supersonic, sonic, and etc. So Mach number is the ratio of velocity of fluid and the speed of sound. Okay, that is called Mach number. If the Mach number is less than 0.3, then the flow is incompressible flow. Okay, if the Mach number is 0.3 less than, then the flow is incompressible flow. So this is the important thing you have to know. So next we will discuss something. Sonic, supersonic, and hypersonic. What is this? Subsonic. If the Mach number is less than 1 and the fluid is flow position, then the flow is subsonic. If the Mach number is 1, then the flow is sonic. Supersonic. What is supersonic? If the Mach number is greater than 1, then the flow is supersonic. Mach number is greater than 1 means what? The Mach number is greater than means fluid flow, what are earlier we studied, that is velocity of fluid and the speed of sound. Okay. So here, if Mach number is greater than 1, that means fluid flow greater than speed of sound. If a fighter jet, this is a fighter jet, you all know that a fighter jet is moving and the velocity of this fighter jet is greater than speed of sound. Then you can focus there will be a supersonic ring. Supersonic ring. That is, we can see there is some foggy ring. Okay, that's called supersonic ring. If the fighter jet is moving and the speed of fighter jet is greater than speed of sound, then we can say this flow is supersonic. In this fighter jet, the jet fuel and the gas is the fluid and the flow. Okay. So I hope the definition of subsonic, supersonic, and sonic is clear. Okay. Now let me clear. So next, what is viscosity? What is viscosity? So viscosity is the fluid property that represents internal resistance fluid to motion. Okay, this is the basic definition. It is denoted by mu. Viscosity mu is called dynamic viscosity. And then we'll come to kinetic viscosity. What is kinetic viscosity? If the viscosity is divided by density, that means the dynamic viscosity, if we divide by density, then this viscosity is called kinetic viscosity. Okay. I hope the definition of kinetic viscosity is clear. Now we will come to the surface tension. So what is surface tension? So surface tension is the tendency of liquid surface at rest to sink into the minimum surface are possible. Okay. In water, in a glass, suppose there is a water. If we take a thin pin, a thin pin, okay, then the pin will flow. So that means for what? This is for surface tension. Wait, not even. Wait. For surface tension, we can see the pin will stay at the surface of the water. Okay. So this was the definition of surface tension. This was the lecture 1, which was a basic definition I cleared. So from next lecture, we will start our main thing, or we can discuss in next class some basic definition like that. Then after that, we can start our main topic in fluid dynamics. So okay, that was the lecture. So thank you.